Hi there, I'm going to try a 6-layer feather carbon cell, both sides with the 3 layers per side of the feather carbon, and the total weight is 3.02 grams of carbon plus paper towel and binder, so we're very low on the sugar. I'll just plug the light in and check it out under this thing. I'm going to do a scope of it as well, see if we can see anything. Can't really see anything with that. It's not too well covered. They're only covered on one side. I'm going to have the blank sides facing each other, so I'm not sure how the cell will actually perform, but we'll see if there's a difference. And this cell, the 1-layer feather carbon from this morning's charge, is still 1.3 volts, and for a short circuit it's on the 10 amp range. It's 140 milliamp short circuit still. So it's still it's not too bad for the size. It's more graphite plate than anything. I got a loose connector. Alright, we got 0.9. Oh, that's counting up. Alright, I'll put the cell together, let it soak for a bit, and I'll get back. And that noise you hear is the ball mill grinding up the activated sugar carbon and graphite carbon. I'll have that off soon. Alrighty, I've got the 6-layer cell together. I'm not sure which one's going to be the negative or the positive. Oh, my leads are falling over again. Oh, no, broke it. Technical difficulty. Got a little red lead. Try that one first. And that one. Wrong way. Okay, to recap, this is the 6-layer feather carbon cell, both sides, same carbon, and for a short circuit, uncharged, just about 2 minutes ago, soaking in that electrolyte, so not very long, and only 0.3 milliamps, so, oh no, it's 20 milliamps actually, because it's on the 10 milliamp range. So we got about a 20 milliamp short circuit and bugger all voltage. Alright, so I'll give it a quick zap with the charger. Right, where charge voltage is just under the 5, so around about 4 volts. I should really replace that with a digital display. Alright, so quick 20-second charge. Okay, that's about 20 seconds. We'll drop in voltage rapidly, but I don't think the electrolyte's soaked all the way in. But for a short circuit, 300 milliamps, dropping 0.5 voltage, so we've got 0.5 bounce back, and running the load 60 milliamps. So that's about 20 seconds. We got 40 milliamps for 20 seconds on a 20-second charge. Yeah. But I think we pumped in probably 400. Alright, so I'll give it a 10-minute charge and I'll get back and we'll see how that goes. I'll start off at 5 minutes. Don't go too fast, we'll burn the cell out like I normally do. Alright, I'll be back in 5. Okay, the cell's almost 11 minutes charge time. It's only on 4 volts, so we're at 2.3. Okay, we're ready for our first discharge of a 6-layer, all the same carbon, feather carbon cell. Alright, so it's looking good now. We'll see after the second charge if it does this. So it looks like it layers. I was surprised because it's only painted on one side. That might be helping it, perhaps. Stopping the leakage maybe. And it's all the carbon feather, both sides, 3 layers on one side, 3 layers the other side. And we're nearly, no, we don't get a minute at 2. But still, it's not too bad considering that's the size of the cell and surface area. And that yellow browny stuff, that's manganese dioxide separating. That's why I'm hoping that all the same carbon will work. Manganese dioxide goes over to the negative side plate and gunks it up, and the other side plate gets the zinc. I'll let this run and I'll get back. So it's looking like it's only a 9 milliwatt hour cell. I got it at 0.05 cutoff voltage. What happened to the 4? I don't know. So we'll terminate that. I'll give it another longer charge, say 15 minutes. But that's just both carbon, same type of carbon on both sides of the cell. So I guess that's not too bad. 9 milliamps. Alright. When you want to log the power curve, you can clear it. Only for monitoring purposes here, it doesn't clear it and then you don't get your time to be reset. It's easier for a charge just to come here and look at the 0 time to whatever time interval it was at. Alright, so I'll connect the charger. We should see voltage increase. Yep, okay. Charger's still set on 4 volts. And I'll press the monitor so I can keep track of the time, and I'll get back in 15 minutes, thereabouts. Been 13 minutes on charge and it's starting to break down after 8. So we shouldn't probably go more than 8 minutes on a charge. Disconnected that. We're slightly up. Stop the monitoring. I wasn't monitoring current flow. We'd have to reverse the data logger, and that messes with the clips. Touching them all the time, they break off. Ready for a second discharge. 13-minute charge. We're at 2.1 volts. Dropping. Okay, I'll get back when this is done. Okay, so the second run, 12 milliwatt hours on a 13-minute charge. I don't think the cell's actually working that well. The original 6-layered cell does 30 milliwatt hours. So I'll try to clamp it. Wonder if it's got not enough pressure and keep it out of the liquid. 2 clamps. Alright, I've got the cell clamped. Oh, it's going to fall off. Right, yeah. Got the cell clamped with 2 clamps. And I'll try another. Try to give it 15 minutes and see if we get more than 12 milliwatt hours. We sort of creeped up a little bit compared to our first charge. Alright, I'll be back. Okay, this charge is 24 minutes, somewhat stable. I fuzzed around here and put it back in the water, or in its electrolyte. And the charge controller, charger voltage is on 4 volts, but we haven't got past 3.2. And the milliamp reading is 260 milliamps. Alright, so stop the logger. Disconnect the charge. Alright, we're at 2.4. Dropping. Okay, setting third test. So we got about half a minute above 2.1 or 2 last run. And that was 13 minutes. This was, I forgot, 25 minutes, was it? I'll look at the video again. The cell could not be soaked in yet, so I'll leave it overnight before I pull it apart, but I was thinking it's not working because it should yield a bit more. I think 2 basic graphite plates make 9 milliamp. Oh, it was 6 milliamps, so it might be working a little bit. You could push them. Alright, I'll let this run its course and get back. Won't be too long, I don't think. It's dropping quickly. Oh, I still haven't changed the time, but I'll get back with that. Okay, so this run only 16 milliwatt hours, slightly up. Milliwatt hours, I should say. Slightly up, and voltage rebound is only 1. It's been sitting here probably for a while now. So I'm not sure on that cell. I'll see what happens tomorrow, and that's it. I will catch you tomorrow. Hi there. It's the 3rd day since the cell's been in the electrolyte, so it's had plenty of time to absorb stuff. I've just given it a 15-minute charge. We're just monitoring the voltage here. Saves swapping all the leads around all the time. I'll just disconnect that. 2.4. I'll stop the monitoring and we're ready for a 0 amp run. I'm going to put 50 milliamp run. And here we go. Still making noise. Shouldn't even be spinning that fast. Uh-oh. I think it's dusting up. Alright, I'll let it do its thing and I'll get back and hopefully it's a bit more than 12 milliwatt hours. Well, it was only 11 milliwatt hours, so I'm still not impressed with the cell, but there is a small amount of carbon on each of those pads and they may not be functioning. Could just be these plates were doing all the work. So what I'm going to do, I've got the stuff grinding now. I don't have any more of that feather material until later, but I have the sugar, activated sugar one. I'll just actually coat them on the graphite plate instead. I think that's a better way. Okay, well, I'm going to wrap it up for this cell, I think, because it's only 11 milliwatt hours and that was a 13-minute charge, so that's about it for this cell. So thanks for watching. Okay, day 3 still. I'm going to do a second charge, 13 minutes on charge. I'm going to do a 10 milliamp load. I think my 50 milliamps far too much for the little cell. So disconnecting the power. Oh, stop monitoring. And we're ready for a discharge. 10 milliamps. That should hold 2.3 or 2 for a while, one would hope. The other day it did run that motor for a half hour on a 10-minute charge, so 10 milliamps should be at least half hour here. We're probably going to get a minute above 2 volts. So it makes me wonder, how do we know what sort of milliamps to test our load at, our cells? So you can change the milliamps and get different results on milliwatt hours. Well, I think we'll find out if that was actually true. So we got a minute over 2 volts, so I'll let it do its thing and see how long it actually will run for on a 10 milliamp load. Okay, it's somewhat just stopped. It's still increasing in its voltage bounce back, so it was only 15 milliwatt hours at 10 milliamps as a load. An hour and 16 minutes it ran for. It looks impressive, but the graph is similar shape. We still have this strange setup here, and then it slowly goes into a capacitor sort of straight drop. So I think I'll put that cell to sleep and wait for the carbon to grind. It's been grinding now for probably around about 30 hours. It's probably overkill. Might stop it later today and get ready to make a cell. This time, and I have an idea. I might be able to salvage the chicken feather by soaking this in some acetone and dissolving the membrane again, collecting it, and painting the rest, what's in the bowl, on the graphite collector. So I'll do that actually. I'll have this soaked by the end of the day. Alright, so I'll post this video and get back on this and the other carbon. Alright, thanks for watching.